Cheers. Well, thank you very much, and hello everyone. Just by way of very quick introduction, my name is Liam, and I live in the Netherlands, and I do systems and solution architecture for a company. And yeah, so today we're going to talk about systemic complexity. And as I was going through these slides, you notice the excellent artwork for this is that the more I looked at them, the more I felt that they're a bit like the kind of live, laugh, love, Instagram, Prosecco time nonsense that you would see in, well, potentially my timeline. And so, yeah, enjoy the slides. They're all like this. So first up, if I can change slides, will always help, is really this. I'm not going to read off the entire thing, but really that the idea of what we talk about systemic complexity and systems themselves is that is they're not the thing. Every time that we look at an image of that, is that the if we have an abstract view of something, is that is not the system. It is never the system. And also the other side of that is that the if you have a whole other system, you know, I can completely copy the entire thing. It doesn't give me any further insight necessarily into what it does. It allows me to try it and give it a go, but it's not the one that we want. So, so you know, if I clone myself, doesn't then give me any better understanding of how my pancreas works unless I go digging around in that one. The idea is that the more that we look at systems and we provide abstract views of that, and we kind of build up and build up and build up to better understanding of it. But there is also then, as well as these diagrams and state flow diagrams and wordy descriptions and test beds, is that we're still viewing this whole room through a keyhole. And then we factor in another things that only we have these wordy bits in the diagrams, is there is a time element to this. And then we have a look at, when we talk about state flow diagrams, is that I assume that if we look at a stop and wait protocol like TCP, is that, oh, I assume that everything's going to work in this point while we're waiting for something to happen. The port is opened and we're sat there listening for a SYN or something that's going to come in or close down. Every time that we model that in some way is a little better insight into it, but it's not the thing. It's still far abstract from the thing. And the other part with that is that we have a little model. Let's say we build a test bed, is that the scale doesn't necessarily work when we introduce those from our little test bed into a larger solution. There's more factors coming in. So do we have a full understanding, sorry, what is the underlying infrastructure and the process in which that it's used? Or if I look at a hello world as a serverless code, think of all of the stacks that sat underneath that and our communication with that service, and Azure or GCP or something else, all of those things that we kind of are relevant to us because our viewpoint is very, very narrow on there. But then I can give you a diagram that shows how my interaction with it works, but it's still not the system. And so to sum up on that is that the chart is not the patient, which is easier to remember than all of this one. And in that as well, let's have a look at me and pictures of cats. And so we have, you know, our HTTP request, and we have a view of how those, or as I'm flicking through slides, and they're not coming up as quickly. You know, here's the HTTP responses. Here's what content delivery looks like. Here's what the web page looks like. There's a whole other things that's going on that we don't capture within this, and is impossible to capture because the systems are so large. And when I say systems, that means that not necessarily like the ones where you have, you know, expanding across multiple regions. Your machine on your desktop is still a complex system. There's so much stuff in there that your abstract view of that and your interface with it is very, very narrow. And so within this, that we don't capture, you know, the fact that the page rendered, and there's the cables and the fiber and the stacks and the switches and the routers and everything that connects me and my machine to Google's massive trove of cat pictures. And then there's the bit beyond that as well, is that my interaction with the machine is rendered on a page. My monitor displays that. I have a look at pictures of cats, and my brain releases some serotonin, and I have the experience unbridled joy. That's still part of the system end to end that we don't model, and we just have a look at. Certainly technology, and I'm very guilty of it, is to look at what is the process that's going on. Would just be, but we requested a page and the page was served, and the various parts of that page were served from here and here. And so it's difficult to hold both that the enormity of this end-to-end cat picture machine, as well as just going and be able to fault find that and to understand that. But the point is at that point that, sorry, point is here is that every time that we produce a view of this is that the chart is not the patient. And so when we have these diagrams, put them into context as to what are we talking about when we have a data flow diagram, or that we have a series of API calls and we're watching that state through there. Why is that useful to us? Is because we need to understand that at an abstract view, because the enormity of it is too much to handle at one go. Everyone experiences that, and so when you're looking at these diagrams in context, is you get a smaller understanding. You build and build and build, and so that sort of brings us on to the illusion of explanatory depth, which is our comfort in what we understand. So if I were to say some of the things that I work on, that how well do I understand that, and I would score that 1 to 10, in my most confident time, say, oh, I'm a good 8 or 9. And at what point do you run out of understanding of that thing? So if I were to ask how a flush toilet works, which presumably we use every single day, or maybe once every 2 days, depending on your cycle, is I could probably explain that to a reasonable depth. And I understand that. So if I score that on 1 to 10, how well do I understand a flush toilet? I'd say a 6 or 7. And at what point do I run out of information? And then if I were to press that further and further, there is a quite shitty interview technique of doing that. So you say, explain to me how FTP works. And then you keep asking the questions until the interviewee runs out of confidence or answers. It's an unpleasant experience having had it, and please don't do it, because it's not very effective. But what it does give you is an understanding of your understanding of it. So if I were to now sit here and explain how a flush toilet works to my understanding, which I won't do, I will spare you that torture, and then reassess that afterwards of what is, on a scale of 1 to 10, what is my understanding of how a flush toilet works? I will at some point stop saying the words flush and toilet. I probably put that at about 2 and a 3 of that. I know that I press the handle and water comes out, and waste then goes away somewhere else. But that in itself is also part of a very narrow view of a larger system. Where's the clean water coming from? Whereas the fouled water going to? How is that processed? How do I then, it comes back out of my tap at some point later, and I still quite happily consume that because it's refreshing and delicious. But I have no further understanding of that. And that is a flush toilet within a complex system. So if the simple devices that we have within our homes are difficult to explain, then what are we doing when we're providing content delivery, or we're providing security solutions, or doing these various technologies? Is that it's never simple, and it's far from simple. But then at the other scale we have, our understanding of it needs to be simple for us to build upon that and build upon that. And the point of this particular slide is not to say you don't understand things as well as you think you do in a mean way. It's to really kind of take that step back and to avoid complacency is one of the things. And the complacency is a killer, because that gives you that things that I know everything, therefore I can assume that then if you're doing particularly in risk assessments, that my understanding of not only my system, but the external threats, the internal threats, and those not just, and any risk from other things. So if we look for risks again, so I work in physical security mainly. If you look at the risks against those, then we have the technology part of that, is that what is going to be the threats to that? Do they include stuff turning up on showdown, people having a pop at it? Absolutely. So we've got that element of it. But what happens when there's a bomb threat in the building next door, and our building is then evacuated, and there's including the guarding? Because what you have in bomb threats is that you will have what's called a 500-meter exclusion zone, which is to it doesn't matter whether you would like to be continuing working in there, particularly if you want to protect the building, is that certainly the UK, someone from Plod will come along and say, please retire to this point. So your building's entirely empty, the things that are running in your SOC and everything else is now empty, and there's no one in there. And you put in your BC processes, but in your threat modeling, did you think of the building next door? Did you think of someone with a backhoe pulling up the cables into your data center? Did you think of heavy flooding and rain in an area that doesn't necessarily have that? And so you've got this issue of the complacency of saying that I understand everything and I have modeled everything, versus you probably haven't scratched the surface. And that's okay, because then we rely on each other, and we rely on prior learning, and we rely on experience and trying these things. But it also brings us to another one, which is this is the sort of post-event thing. And I'll thank Nico, who said that when this when the slide was originally up and he had a review of it, it was just like, yeah, it's like slide 6 is oof. And so I've adjusted the contrast. Hopefully that's now readable. Is that hindsight bias is this kind of post-event thing. So if I give you a crossword with the answers filled out and you have a look at the answers, the questions, you go, oh, of course I would get that one. And it's very easy to slip into that mindset. So if you sit into a post-mortem for an incident where there is it's been caused by a particular thing, you go, well, of course we thought of that thing. Well, actually, we have a very complex moving system of all the things that as we've demonstrated, we don't know about. We've got the answer. Well, of course that's a thing. And that makes it difficult. Why didn't the people in the SOC notice that? Why didn't the people on the front desk notice that? Why didn't so the point of understanding that hindsight bias is there and it gives us the answer was obvious all along, it absolutely wasn't. You're far from the answer at all times. And so this is another one where it's not a telling off, like with the illusion of explanatory depth. It's really to understand that when you're looking back at these things is what is the process or the break in the process or system that brought you to that point, and allowed maybe a human element to it, but is to really put into be constructive in understanding that hindsight bias is a thing. One of the worst that you get is that you get a major incident that we see quite often, and Twitter goes absolutely crazy for it. How did they miss this? And so because they're looking at everything else. If you look at Heartbleed, there's 2 lines somewhere stuck in the middle of the 2 million lines of code. Well, this is ridiculous. Why would a request for a heartbeat respond with massive chunks of memory? You go, well, of course it'll be that thing, and it's very easy to get caught in that thinking trap. And the point is that there's 2 million lines of code. Who's reviewing it? And I know very, very happy with the open source movement, is that if you've got that many eyes on it, why did we miss this? And the problem there is that not everyone's competent, capable, looking in the right places. So that's much harder to know how to deal with that. So what is the process that would prevent that from happening? Is it code review of 2 million lines of code in a moving target? Good luck. When I first started my career, was in software engineering in avionics for a defense contractor, and we had code reviews. Even the smallest thing was sat in a room of 5 or 6 people going through line by line, because these were going to go into military aircraft. So you really need to know what's going on in there. And I've fallen asleep in more than one of those. You can do that for 2 million lines of code. That's a long time to do. But then there's the risk associated with that. So it's the payoff of spending that time to do it. Is that the right process? Probably not. But that's a process that needs to be looked at, and not the fact that there's a janky line of code in there. And then even with that as well, is that we have another problem, is that within a complex solution, is that you can't just change one thing, because it's all it shouldn't be closely coupled, but there are interactions between any one component and any other component. This is all interlinked. At the same time, you can't just wholesale lift and shift the solution out of there. We see this at the time. If you look at Outlook, which has replaced various versions of Outlook and other mail servers as well, is that you've still got hangovers from when mail was open port, whichever one it was. I'm going to say 25, and someone will call me out on it. And then you say, yeah, hello, and then you could type it on the command line. You still got hangovers from that in there. The solution hasn't changed, but I've still got a nice shiny interface, and I can do this on a 365, and it's all cloud-based. But the system has a will to live, and what that means is that there's no new thing. It still has hangovers. If you look at if you design a new solution, is that part of the process and the way that it's worked and the look and the feel will still be looking a bit like it was previously, or your requirement set will be based on what you had previously. And that really puts you into quite the pickle. And the other point of that as well is that you end up with the new, is that now you've got something entirely untested. And so you spent all this time having a look at and tailoring and closing out some of these issues with previous versions. Now you've got a brand new shiny thing with a whole load of new unknowns, except for your design time documents, the source code. You still don't know how good it is until it's tested and it's been bedded in. So, I work in an industry where we will never, I'm sure others do, never take version 1 of anything, never take an early release of anything. And we sit back and we wait for other people to do stuff. And that leaves us with a lag on things, which has its own problems as well, particularly in patching. Whereas get those 0 days sorted out, no, we'll sit on it for 6 months. But that requires going through a process of assessing those. And so you get stuck in this waiting for someone else to see if it breaks first. But then is that the assumption then that they have cleaned and closed out everything that's there? We just look back at OpenSSL and say, well, we had various versions of that, and at no point did they catch that. Or the other side of that was that put in there deliberately. But that is that's a whole other talk for someone else better than me. And so for changing things, for making these changes, is you will go through these kind of OODA type loops, or this kind of cycle of observe, orientate, decide, act. Someone else will do it. This is not an academic talk. And so I wouldn't recommend OODA as a thing, but it's just a case of going through this of what are you changing? What is the impact of that? One of the biggest issues with that is that by changing one thing, you don't know what the outcome of that will be. And we're back to this issue of our models previously, is that I can make a good assumption on what I think this impact is going to be until you're at 2 o'clock in the morning trying to rip stuff out or patch it or make a decision to roll back. And of a project that's taken 6 months in planning, it's an unpleasant experience, but sometimes you don't know until that's put in and tested. I didn't set my timer, so I'm going off my clock on my machine, so in all the excitement. And so I think I'm good for time. I'm sure someone will tell me if I'm not. So this brings on to, we're right towards the end of this at the moment, but I wanted to go back on a couple of items. And one of these is that the safety, which is the slide that I stole this off, is an emergent property. And by safety also means security as well, as it is encompassed in that. And when we talk about safety and security, and that the fact that the system works, we can kind of all encompass these in a phrase called correctness. So this is, does it work how you want it to work? And so sometimes that means safety, sometimes that means security, sometimes it means that I press the button and then a meeting room is booked or something similar. They're all the same thing. Obviously, from our point of view, we're very precious. Security is absolute king. But really, if you look at a system and its correctness in its operation is the target that we're going for. And I'm trying desperately not to use the move security to the left or bake it in from the start, but right at the start is we need the system to work. And if the system to work also includes we need the system to work, and that includes security, then it's already there at that point, and we're not doing last minute Charlie, these code reviews just for a push, and sort of getting involved in the sprint planning when we're on some cycle 6 or 7 when we should have been there at the start. And the other part of that is a bleating on about how security is just simply the system working well is this concept of being an emergent property, is that it doesn't mean that I put in a new box or a new upgrade the firewall and security is done. It's a combination, a culmination of things that are there. So are you doing input checking on forms? Is the right information in there? That's correctness of the solution. Is the inputs that we're getting from external sources correct as well? Are we processing that well? Are we outputting that well? And I'm trying to avoid saying the word securely, because what I just mean is that it works, which sounds very fundamental. And what I'm trying to desperately avoid is making security this special thing. I'm very aware of the audience when I say that. Security is not a special thing. It should not be a special thing, in the same way that safety shouldn't be a special thing. You walk into a plant room in a factory floor, it should be safe. And there should be measures in there to prevent me from doing stupid things, but also including that as processes to prevent me from doing stupid things. And maybe a PPE or an escort to stop me from doing that. And we take that for granted until there's an accident. And security should be exactly the same. There should be those processes in place to stop me from doing that, to educate better. And they should be subtle and in the background without having to do what we do now, which is jumping up and down until we have budget and time and resource to be able to do these things. I'm very aware of preaching to the converted. It'd be nice to have these conversations with the grown-ups in companies as well. So the idea is that this is not something that is special. We kind of lose some of the luster and the sort of badge of honor when we do that, when we're just part of the furniture. But I promise you, that's exactly where we want to be, and just a thing that happens in the same way that the system working does. Just guessing on time, because I think I'm 21 minutes in, but I may not be. That does leave a little bit of time for questions as well. I think in my early morning eagerness and nervousness, I blasted through faster than I expected.
That's great, absolutely great. You're actually running only a few minutes early, so don't worry too much about that. We've had plenty of comments and appreciation for your talk, Liam. So I don't believe there are any questions. Any questions kicking around in there?
I haven't seen, but some just really positive comments about the state of affairs, and basically, that the philosophy of safety and the philosophies of security are, almost sometimes diametrically opposed. And your contention that they really need to be more aligned, and we need to have that philosophical, I think, alignment is like a really great thing. And I really enjoyed the presentation, man. Excellent insight into the conditions that are out there in terms of like relationships and how it all comes together. Yeah. Really great stuff.
Yeah, I agree. Completely agree. So on that note, Liam, we just want to say thank you very much on behalf of ourselves and on behalf of the people watching. Have a great weekend, and cheers.
Cheers. Thanks, chaps.